All right, your warm-up problems today. Determine which direction the parabola opens and name the vertex as an ordered pair. Again, the main equation that we're working with here is the vertex form of a parabola, which is y equals a times x minus h quantity squared plus k. A is what's going to determine which direction it opens. H and K are going to give me my vertex. So for number 1, y equals negative 1/2 times the quantity x minus 4 squared minus 3. Which direction is this one going to open? Is this going to open up or down?
Down.
Down. The negative 1/2 means this is going to open down. And what is going to be my vertex? 4, negative 3. Because there's my A, my H, and my K in that equation. And what we had, the key here is with H, we have to remember it's going to be opposite of what we see. If we see a minus 4, that means H is positive. If we see a plus, that means that H is negative. So number 2, y equals negative 1 times the quantity x plus 4 squared minus 2. So again, A, H, and K. Which direction does this one open?
Down.
Down. Even though it's just the minus sign, remember that's like it's a negative 1. So that's still an opens down. And what is my vertex? Yeah, it's negative 4, negative 2. That plus 4. And that's going to be the one thing that's going to trip us up, is remembering to take the opposite of what we see there with that H. Number 3, y equals the quantity x minus 4 squared minus 3. So there's still an A, an H, and a K. So is this one going to open up or open down? Yeah, that positive 1 there. So this opens up. And my vertex, 4, negative 3. And we're going to be using some of those ideas today as we go. We're still just working on transformations. How do these numbers affect an equation, and looking at it from different parts? Again, there's no new information today. We're just going to review some of the information that we've previously talked about in this unit so far. Again, that vertex form. And that's going to be important because one of your parts today is going to give you some information and ask you to write the equation in vertex form based on the information that you are given. And again, for A, positive opens up, negative opens down, And I didn't really talk about this with A as far as compression and stretch go, but we're really looking at the absolute value of it because I just want to know what the number is. The positive or negative determines if it opens up or down. So the absolute value of A greater than 1, we have vertical stretch. The absolute value of A less than 1, we have vertical compression. And stretch just means it's going to be narrower because it's growing at a faster rate of pace. Compression means it's going to be wider because it's growing at a slower rate of pace. The ordered pair HK is the vertex of the parabola. And because that vertex is made up of an x coordinate and a y coordinate, even though we're using the letters H and K here, it's giving you the shift from the origin of the graph, basically. H is the shift up or down. Excuse me, H is the shift left or right, sorry. And K is your shift up or down. So again, this is just a review of the things that we've talked about over the last couple of days on how these three letters impact the graph going from y equals x squared to y equals a times the quantity x minus h squared plus k. These are the transformations that happen based on those letters. So they want us to name the transformation from the parent graph y equals x squared to the given graph. Well, the graph of y equals x squared obviously doesn't change from time to time. So you have to think about it. If I were to just sketch it in here, the graph of y equals x squared starts at the origin. 1 squared is 1, 2 squared is 4, 3 squared is 9, which is just off my graph. So we do our, and I'm going to put this as a dotted to show So that is our parent graph. And you don't have to graph this each time. I'm just showing you that this is what we're comparing it to. If that's my parent graph, again, which its origin is at 0, or its vertex is at 0, 0. It has points 1, 1, negative 1, 1, negative 1, 1, 2, 4, and negative 2, 4. What had to happen to that graph to get the blue graph we see there? What transformations? And I'm looking for things like shift left, shift right, shift up, shift down, reflect across the x-axis. Those are the descriptions we're looking for here on this set of problems. So starting at that parent graph, what is one transformation that happened here? It's reflected across the x-axis. Anytime it opens, it starts opening upward and ends opening downward. So it is reflect across the x-axis. But that's not the only one, because if it just reflected, I would still have a vertex of 0, 0. What other transformations happened here? Down 1. So my vertex now has a y coordinate of negative 1. Shifted down 1. And 3 to the left. And the order that you list those, there's no, if you had shifted 3 to the left, down 1, and then reflects across the x-axis, it doesn't matter which order you put them in as long as you get all of the transformations. So again, you don't have to draw in the parent graph, but if it helps you as you're doing these problems, you're more than welcome to sketch in. I'm going to do it one more time just because I want us on this next one. So we have our origin, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So I'm going to sketch this in again. So on number 5 here, what are some transformations that happened? It reflects across the x-axis because it is opening down now, so reflects across the x-axis. But again, if it was just that, I would still have an origin of 0, 0, and I don't have that. Shifts 3 to the right. And this one actually does one more thing. It gets narrower, so we're going to say that it has vertical stretch. which again in essence means it is narrower than the parent graph. And this one, because the vertex is still on the x-axis, we don't have an up or down shift, and that's okay. You don't have to have up and down every time you have left and right, and vice versa. You could have an up or down without a left or right. All right, so if we look at number 6 here, again, if it helps you, graph in that parent function. So what has happened here from the parent function to the new function? Yeah, shifted up 3. So this one did not move left or right. So shifts up 3. And it is wider than the original, which means it is the vertical compression. And just know it is possible to have all of them. It is possible, well, not all of them, because you can't have compression and stretch at the same time. But it is possible to have it reflect across the x-axis, shift left or right, shift up or down, and have either compression or stretch. So it is possible to have all of those, but it doesn't have to. All right, so on number 7, I've drawn in the parent function. So what are the transformations that have happened here? So it's shifted down 5. Okay, we didn't have a reflection. We don't have vertical stretch or vertical compression here. We just have a basic shift. So it's just being able to know what the parent function should look like and understanding what has happened. Now we're doing the same thing, but we're doing it from an equation versus doing it from the graph. The graph is a little easier because you have a visual picture. But now we're going to look at an equation and be able to talk about those same terms we just had. So again, I have my A, my H, and my K. And the things I have to look at is A is +1. +1 means it's the same as the parent function, so it's opening the same direction, it's the same width. So I know I don't have vertical compression or vertical stretch, and it opens upwards, so I don't have a reflection. So now I'm just looking for my shift. So if I have h is -9 and k is -6, what type of shift has happened in this equation? Yeah, this shifts down 9, or excuse me, shifts to the left 9 and down 6. Or if you want to say shifts down 6 and left 9.
Does the squared part not really matter?
For transformations, no, the squared part is simply telling us we have a quadratic so that we can put all this information together. The squared part does matter as far as it being a quadratic function, but the transformation part of it, no. The squared part is simply telling us we have a quadratic function and we're looking at these different values.
When I'm graphing it, it doesn't really matter.
Well, the squared part does matter when we're graphing because that's what gives us that symmetrical shape. Because when I square a positive number and I square a negative number, I still get a positive. So if I square positive 5, I get 25. If I square negative 5, I get positive 25. So the squared is what gives us that symmetrical shape, because when I square a number, whether it's positive or negative, it always comes out to be a positive. So that's really where the squared gives us the shape. All right, number 9, y equals 1/5 times the quantity x plus 13 squared. So I have my a, my h, and remember, if there's nothing there, there's still a k, but if it's a 0, it doesn't affect, 0 doesn't move up or down. So in this one, a is 1/5 and h is -13. What type of transformation has happened here? Well, if a is 1/5, what does that do to the graph? Does that make it wider or narrower?
Wider.
Wider. So we have vertical compression. So it's going to be wider than the parent graph. It's positive, so it's still opening upward, so we do not have a reflection. And because k is 0, we only have a shift left or right. If that is x plus 13, that means that h equals -13. So this one shifts left 13. We don't have an up or down because of that +0 or the k not being written in the equation. Number 10, y equals -1 times the quantity x plus 14 squared minus 22. So a, h, and k. What are some of the transformations that are happening from the parent graph or the parent function to this? If a is -1, which direction is it going to open? Down, which means it reflects across the x-axis. H would be -14 and k is -22.
Why did we reflect this one across the x-axis, but we didn't?
Because the other ones are positive. You only reflect when A is negative. Because the negative is what causes the parabola to open downward. So you only have a reflection if it's opening, if A is negative, has a negative value, it's going to open downward. If A is positive, it's opening the same direction and you don't have a reflection, you just have a shift.
Oh wait, I'm sorry, I thought it was
Yeah, we have to think about that negative outside is really representing -1 times. So this one is going to shift left 14 and down 22. Now the last part is going backwards from this. They're going to give us the reflection and we have to give them the equation based on what we are told. So now we're working the other direction. So it says write a new equation in vertex form for the transformation listed given the parent function y equals x squared. So the graph shifts right 5 and up 3. Right 5. So right 5. That right there tells me that h equals 5. Up 3 tells me that k equals 3. It didn't reflect. It didn't vertically stretch. It didn't vertically compress. So there's no change in A. So when I write this, this would be y equals the quantity x minus 5 squared plus 3. There was no change to the A value in this equation based on the information given. Number 12, the graph shifts 3 left and has a vertical stretch of 5. So left 3 tells me that h equals -3. Vertical stretch of 5 means that A is going to equal 5. Now, when I put this in, so y equals 5 times the quantity x minus a -3 squared, I end up with that double negative, which is how we get the positive. So y equals 5 times x plus 3 squared. Number 13, the graph shifts down 4 and has a vertical compression of 1/3. So down 4 means that k equals -4. vertical compression of 1/3 means that A equals 1/3. So y equals 1/3 times x. There was no change in my h, so there's x minus 0 squared minus 4, but we wouldn't really write that x minus 0. We would write this one as y equals 1/3 x squared minus 4. If there's no change to the h, we wouldn't write in the 0. Number 14, the graph shifts 5 units left and 2 units down and is reflected across the x-axis. So 5 units left means that h equals -5. Two units down means that k equals -2. And then it is reflected across the x-axis, which means that a equals -1. So when I substitute all of that in, so y equals -1 times the quantity x minus a -5 quantity squared minus 2. Well, we don't usually write the -1 outside. We would just put the minus sign. So we would rewrite this as y equals -x plus 5 quantity squared minus 2.